In this question, we're told that a train travelled along a track in 110 minutes, correct to the nearest 5 minutes. Jake finds out that the track is 270 kilometres long, and he assumes that the track has been measured correct to the nearest 10 kilometres. And in part A, we are asked to find out whether or not the average speed of the train could have been greater than 160 kilometres per hour. Now the first thing that we need to know is that the average speed is equal to the distance divided by time. Now since we're asked whether or not the average speed of the train could have been greater than 160 km per hour, we need to find the upper bound of the speed and see if the upper bound is more or less than 160. Now since speed is equal to distance over time, we can see that we're working with division. And in order to find the upper bound for division, we do the upper bound of the numerator divided by the lower bound of the denominator in order to get the greatest difference and therefore the greatest value of speed. Now since we have the distance in the numerator and the time in the denominator, let's first find the upper and lower bounds of these values. And so we'll start with distance. We have a distance of 270 kilometers, measured correct to the nearest 10 kilometers, and so the upper bound and lower bound of the distance, the lower bound will be 265, and the upper bound will be 275. Now we can do the same thing for the time. We have a value of 110 minutes, correct to the nearest 5 minutes. And so the upper and lower bounds, the lower bound will be 107.5, and the upper bound will be 112.5. Now we said that the upper bound of the speed is the upper bound of the numerator divided by the lower bound of the denominator. And so we can say that the max speed, the upper bound of the numerator is the upper bound of the distance, which is equal to 275, and the lower bound of the denominator is the lower bound of the time, which is 107.5. But this is where we need to be careful with our units. The speed is given in kilometers per hour. We have the distance in kilometers, but the time given in minutes, and we need to have the time in hours. And so what we can do, we'll continue with the upper bound of the distance, 275, divided by 107.5. Now to convert from minutes to hours, we divide by 60. And so we'll do 175 all divided by 60 in our denominator. And when we plug this value into our calculator, we'll get an answer that the max speed is equal to 153.488371. Now we're asked to find out whether or not the average speed of the train could have been greater than 160 km per hour. Since we found that the maximum speed is 153.5 km per hour, we know that the average speed of the train could not have been greater than 160 km per hour. And so we can write this down as a conclusive statement below. Now part A is worth 4 marks, so let's take a look at where these marks are allocated. Now the first mark is for a process to find both the upper and lower bounds for the distance and for the time, which we've shown clearly in our working. Now the second mark is for a process to find the speed by dividing the distance by the time. Now the third mark is for a process to work in consistent units of time, which we did when we did 107.5 divided by 60, so that the units for the time is in hours rather than minutes, allowing us to get that third mark. Now the fourth and final mark is for a conclusive statement, saying that no, the average speed of the train could not have been greater than 160 km per hour, because we found that the max speed is 153 km per hour, and this is less than 160, allowing us to get the full 4 marks needed for part A. Now in part B, we're told that Jake's assumption was wrong, and that the track was actually measured correct to the nearest 5 kilometers, and we need to explain how this could affect your decision in part A. So if the track was measured correct to the nearest 5 kilometers rather than correct to the nearest 10 kilometers, we'll have a smaller distance covered in the same amount of time. And so since we have a smaller distance, we can therefore say that the value for speed calculated in part A will decrease. And so we can write this down in our answer box below. So now we've said that less distance is covered in the same amount of time, and so the maximum speed calculated in part A will decrease, and this will allow us to get the 1 mark needed for part B.